Hi guys, I am trying a new video method, so hopefully this works out okay. I want to take care of our last lesson in solving quadratics, so this is going to be solving quadratics number 7. And what we're going to do is we are going to learn how to solve systems of quadratics. And if you remember from Math 1, you will remember that graphing a system of equations just means graphing two or more equations at one time. So that is what we are going to be doing today. I have Desmos popped up here in the background so that I can flip back and forth. You'll notice that right here, this is the North Carolina test version. So the functions that we will not have on our final exam, those have already been turned off using this format of Desmos. Okay, so I'm going to be flipping back and forth between those two screens. So when we solve systems graphically, that means using a graph to find the solutions. And when we look for the solutions to a system, all that means is we are looking for the intersection point. We are looking for the point or points, maybe I should put points, where the two graphs are going to cross each other. It's where their coordinates are the exact same at the exact same moment. So for Math 1, when we did systems of linear equations, this was always just one point. So your two lines went like this, and they crossed in that one point. That intersection was the solution. Or if we had parallel lines and they never crossed, then we had no solutions. If our two lines graphed and they were actually the same line, then we had infinitely many solutions. So for Math 2, because we're drawing a quadratic, so a parabola, U-shape, it is possible that I could have a line that goes across my quadratic, which means that I would have two intersections. So doesn't have to be two, but we are usually going to have two intersection points. So let's do number 1. We're going to find the solution by graphing. So I am going to flip over to Desmos, and I'm going to grab my my keyboard, and I am going to type in my two equations. So all you're going to do is you are going to click inside of the box, and if this little keyboard here doesn't pop up, it will look like that. And you can open that up, and right here is where you can find your squared button. So using my keyboard, I'm just going to type in y equals x, and then I'm going to use this button right here to square it, and then -4. And then for my second equation, it's going to be a y equals a -3. So you can see here on the graph, I'm going to grab it and I'm going to zoom in nice and tight. So what you can see is that my y1, that is this green quadratic graphed here, and the purple linear guy, so this line right here, they are going to exist or share the same space right there. When I click on it, the coordinate -1, -3 is one solution, and then +1, -3 is your second solution. So this can be done on a graphing calculator, plugging into y1 into y2, or right here on Desmos, finding those intersections. So let me just do a quick sketch for you here on my paper. So we had our parabola graph like that. So that was y1. And then I plugged in y2 for the linear guy, which went like that. And then my intersection was right there at -1, -3. So that's one solution. And then the other point was right there at +1, -3. +1, -3. So two solutions, okay, two intersection points for this quadratic and this linear guy. Not too bad, huh? All right, let's take a look at number 2. So I'm going to do the same thing with number 2. I am going to plug my first equation into y1. That would be the first equation, and then I'm going to plug that guy into y2. So flipping back to Desmos, grabbing my keyboard. So that first equation, you can just backtrack and leave in your y equals x squared. That'll be helpful to you. So y equals x squared plus x minus 2. And then this one, I'm going to leave in the y equals negative x plus 1. So because the graphs are different, you're just going to have to kind of move them around a little bit. You can zoom in, you can zoom out. So if I zoom out pretty far here, well, actually it's not pretty far if you look at my units, I can see that we are going to have two intersections for this graph. So that guy right there at -3, 4, and then here is another intersection point located at +1, 0. All right, so let me go back. I'll do a quick sketch again for you. So I had my quadratic looking like this. So that was y1. And then my linear equation went like that. So here was one solution or intersection at -3, 4. And then we had this is an intersection at +1, 0. And there it is, two solutions for this system. It was a quadratic and a linear, so two solutions there. All right, let's take a look at number 3. So number 3, I've got a quadratic again, and then I have a linear. So I'm going to put my quadratic in here. I'm going to add a negative out in front of the x squared, and then minus x plus 2, and then move down here. This is going to be a 2x plus 2. Desmos is a free app that you can put on your cell phone if you wanted, and the functionality, it works the same way. So you can use this on your cell phone, or you can just open up a tab. I didn't mess around with my cell phone enough to know if you can get the NC test version of Desmos on your phone, or if it's just the do everything version of Desmos. I will have to research that a little further and let you know. So here's my quadratic, here's my linear. I've got one solution right there at 0, 2. And then I have another solution there at -3, -4. All right, so quick sketch of that. My quadratic was first, and it went like that. And then I had this linear guy, and it went like that. And I had an intersection here at 0, 2. And that's a really bad graph, but oh well, you get the point. There's an intersection there, and that was at -3, -4. So my two solutions, -3, -4, and 0, 2. So a quadratic and a linear giving me two intersections, two solutions for that system of equations. Okay, so now let's talk about no solution. So for linear, like my two pens here, if I had parallel lines that had the same slope, that would mean that those two equations are never going to touch each other, which means that there is never going to be a solution. These two equations do not occupy the same space at the same time. So if I think about what that looks like for no solution, it's the same. It just means that I have two graphs that don't intersect each other. So maybe I've got a quadratic like this, and I have a linear like this, and those two graphs never touch each other. That means that they never intersect, and that means that they have no solution. I'm going to try to pause my recording. Okay, kiddos. Okay, I am sorry about that. I got interrupted by students picking up Chromebooks today. So get back on track. So we have no solution when your two graphs never intersect each other. So another example of that might be a quadratic that opens up and then another one that opens down, and they never intersect each other. So that would be no solution. So let's take a look at number one. It says, given the following system, change only one number so the system has no solution. So I'm going to type in what has been given to me here. So that's going to be a 2x squared plus 3. And then an x plus 5, like that. So you can see that the two solutions are right here, and I need to change one number so that the system has no solution. So if you remember how a linear equation works, it is y equals mx plus b, where m is your slope. In this case, m is 1, so slope is 1. And your plus b, that is your y-intercept. So you can see plus 5, it is crossing through the y-intercept right here at 5. So what if I could take that y-intercept and maybe move it down here so that the linear equation would end up below the quadratic equation? So what should we change that to? How about -2? Would that work? I feel like it did. Yep, there it is. Now that linear equation is sitting well below the quadratic. So, ladies and gentlemen, there are infinite amount of possibilities here, right? You could do a -10. That would go down even farther. You could do a +1. You could do a +2. I wonder if 2.5 would work. I wonder if 2 3/4 would work. Yep, still looks good. Let me zoom it in. See, they do not touch. That is still no solution. So our changing one number, I changed this y-intercept right here. I don't even remember what number I first picked. I'll just say -10. So that means that this equation would get changed to y equals x minus 10. And now there would be no intersection between those two graphs. All right, on the back. So we are doing systems outside of the standard viewing window. So this applies more to the graphing calculator. When you have to use your zoom to change your standard window. So I will show you on the calculator how to change that window, but with Desmos, it is very easy to zoom in and out and to change your screen around. That's one of the benefits of using Desmos, is it's easier to manipulate that window. So I will show you both. So what we're going to do is we are going to graph this system of equations. Let me get my calculator into Math 2 mode instead of calculus mode. And my window, the standard window, the default is -10 to +10 and then -10 to +10. So what I'm going to do is I'm going to go into my y1 and say x squared minus 11x minus 36 and a -12x plus 36. And then when I go to graph it to look at my solutions, it's still working. See that little guy right there? So at first glance, it looks like these two guys, they're not parallel. Like this one red one's tilted a little more, but I definitely can't see where the intersection is. So what you have to do is you have to go to zoom, and you can zoom in and you can zoom out, but really the best one to use if you arrow up is zoom fit. So your calculator will automatically pick I'm trying to get a good look at it here. Your calculator will automatically pick a window for you that is appropriate for the graphs that you have put in. So by doing that, it'll reformat your window appropriate so that you can see that intersection and you can see that intersection. So outside of the standard window, because I know that this X already is going to be at a -9. So if I went into my table of values and I scrolled back to X is -9, I want you to see why you can't see that in a normal window. Yeah, because the Y value is 144. That's why you could not see it. That's why when I look at my graph now, you can't even see individual units on the Y because the individual units are very, very large. So sometimes if you're on your calculator, it looks like there might be no solution, but you just have to zoom 0 and that will zoom fit your window. So let me write that on here. In your calculator, you want to go to zoom 0, which is called zoom fit. And that will give you a customized window for your particular equation. We don't run into those problems on Desmos. Let me grab my keyboard again. We don't run into those problems because of our mouse. X squared minus 11x minus 36, and then let's see, negative 12x plus 36. So I can just grab and drag, and I can use the little wheel on my mouse, and I can see my intersections that way. So there is one intersection, and it's right there at +8, -60. And then I can drag my graph pretty high up. I already know it's way up there at 144. And I can find my intersection. It's right there at -9, 144. So using Desmos makes the window not an issue, makes it a non-issue. So that was one of my solutions, and this is one of my solutions. So part about technology is knowing when it is easier and faster to use one type of tool versus another. So sometimes the calculator does things easier than Desmos does, or sometimes Desmos doesn't do the thing that you need it to do. And then sometimes it's just better to use Desmos. It is more convenient. So I'm just typing in my example number 5 right now so that I can find my intersection. So it looks like I have an intersection right there at 7, 114. And then if I just click and scroll, I have another one right there at -6, -42. So if I'm the one that's taking your final exam and I'm doing these types of problems, I am allowing my calculator to sit on my desk, and I am using Desmos to do these problems. Desmos is definitely the easier and the faster way to work through these guys. There's going to be things later on that we do that it's just better to look at and to punch things into your calculator. While I have this open, I want to show you how I can look at a table of values. I'm a table of values girl in my calculator. I really like the functionality of that, and you still have that here in Desmos. So if you go and you click on the little gear, it is the edit list. You can say, I want to view this as a table. So now you have a table of values. And if you want to know something specific, like, I wonder what is the Y value when X is 13. All you have to do is punch in 13 and it'll give you that Y value. And then the same thing here. So I'm going to click on my gear and I say, I want that to view as a table of values as well. The only, I guess, not great thing, like when you are in your calculator, I like that the Y1 and Y2s are right next to each other. I feel like in Desmos, them being stacked on top of each other like that visually doesn't look as nice, but you know, you'll gain some, you'll lose some, right? Okay, so what did we say? Oh, maybe I didn't do that one yet. I don't think I did that one. Okay.
Teachers, this is Mr. Madden. If you would.
Sorry, guys, just had to pause again because Mr. Madden made an announcement for us about Chromebooks. Okay, so I am on number 6. So I'm just going to X out of those so that I can type in a fresh new equation. So I've got a Y equals X squared minus 2X minus 2. And then my second equation is Y equals negative 2X plus 2. All right, so here are my intersections. I'm gonna zoom in and I've got one right there at positive 2, negative 2, and one right there at negative 2, positive 6. And really, how easy is it just to toggle back and forth between your tabs, punching in your equations, and then filling out your paper? Let's see, number 7. Number 7 is going to be a, oops, that's not what I wanted, a 2x squared minus 24x plus 76. And then this bottom one is just going to be a horizontal line at y equals 3. So check this out. So those two equations are never going to cross each other. They are never going to cross each other. Your quadratic is up here and your linear is down here. So that means our intersection points, there is no solution. Easy peasy when there is no solution. All right, last problem's down here. It says, what if my equation is not in y equals? So you will need to make sure that your equation is in y equals. So whether you are putting it into the North Carolina test version, we can try that and see if I can type in this version. I may or may not. If you are using your calculator, you definitely have to have things into y equals before you can go to y equals and punch in your equation. So number 8, the first equation is already set up perfectly. So I am going to type that guy in. That's going to be a 4x squared. And then a plus 20, and then a minus 29. Okay, so I'm going to try to type in exactly as I see it, 8x plus y equals 20, and it graphed it right there. That's the line. So when you are in Desmos, even in the North Carolina testing version, you don't have to put it into y equals. You can punch it in exactly as you see it, and you can find your intersections. Is that the right number? I've got 8x plus y. Oh, hello, look at, I put a 7x squared when it should be a 4x. I'm like, okay, something did not feel right about that. All right, so let me zoom in a little bit so I can see this intersection. So it is a decimal. So if it's a multiple choice answer, then you can find that decimal that matches, or you can give an approximation if they have rounded decimals. So I'm going to make this approximately 1.5, and then I'm going to make this approximately 8.4. And if I drag and click up to my other intersection, we'll see that is a decimal as well. I'm going to make that a negative 8.5. And then this is going to be approximately 87.6. So my intersection points are going to be approximately 1.5 comma 8.4 and negative 8.5 comma 87.5. Now, some of you are like, Ms. Smith, I prefer a calculator. I totally get it. How do I make this into y equals? Well, to get y by itself, that means that this 8x has got to go. I subtract 8x on both sides. So I get y equals negative 8x plus, because that's a positive 20. This is the thing that you would be putting into your y2 equation, and that would be your y1. So on Desmos, you can type in exactly as you see it, which is amazingly convenient. And if it's going in on your calculator, well, then you have an extra step to do, and you have to make it y equals. So on this last one, first equation would be just fine. I'm going to practice putting that into y equals, and then I will just finish it off on Desmos. So to get y by itself, I am going to add x on both sides. So y equals a positive x and plus 3, a positive 3. So if you needed, that would go in on your calculator. I've got Desmos open, so I might as well use it. So I'm going to change that to a negative x squared minus 8x, and then a minus 15. And then this guy, I'm just going to do a total rewrite. I've got a negative x plus y equals 3. All right, I can't see anything, so I need to zoom it. Here we go. All right, so I have two solutions. I have two intersection points, one right there at negative 6 comma negative 3, and one right there at negative 3 comma 0. So let me write that in there. So I've already gotten a couple of questions on using Desmos. I hope that me using Desmos with this lesson right here was helpful to you. Remember, to get to Desmos, all you have to do is Google Desmos, D-E-S-M-O-S, and you want to do NC after that. Then you can pick the North Carolina testing version so that you are working in the one that will simulate what you are going to be using on your final exam. Okie dokie, that is it. Believe it or not, I already missed your faces. All right, we will talk to you soon. Bye.